here's the solution to one of the problems from Chapter 11 homework, the last homework set. In this case, they're telling us the data, the counts that we need for our contingency table, but they're telling it to us in words at the beginning of the problem, and asking us as the first step to move them to the table. So let me just point out why we know enough to do this. They say a study was done to see which subjects who had suffered from a stroke were given either a placebo or aspirin. 3 years later, and this is where they start telling us the data, 32 out of 690 subjects taking placebo had a heart attack, and 21 of 681 subjects taking aspirin had a heart attack. So the people that had a heart attack, 32 were taking a placebo, so that's the placebo who had a heart attack. 21 people who had a heart attack were taking aspirin, so that's this number. 21 of the people taking aspirin had a heart attack. So they're telling us that 31 and 21 here, and they're also telling us that 690 people had placebo and 681 people had aspirin. So they're telling us these numbers and these totals. And so by subtracting, I can figure out the two numbers that go here, and of course I have to add to get the totals underneath. So this is the thing that they didn't tell us. They told us 32 and 690. We have to subtract to find that 658 people on the placebo did not have a heart attack. And similarly, we have to subtract to find out that 660 people who were taking aspirin did not have a heart attack. And then, of course, we have to add the numbers ourselves to get these sums down here. So all of the information that we need is in this sentence. So the first step would be to build the table. Now, once we have the table, this is the table of numbers, just the counts, not the totals. This is the numbers that in your calculator will go into matrix A. So remember, you have to bring up your matrix menu and type edit matrix A, make it 2 by 2, and type these counts in. Once you have that, you can run the chi-square test. Remember, chi is this thing that looks like an X. So that's in your stat test menu. That'll allow you to tell it that you want to run the chi-square test on the observed counts in matrix A, and you just hit calculate, and it will do the test for you. Now, the minimum requirements for the test, the rest of these questions, again, these are not things I normally ask on a test because it's the sort of thing you should look up when you're going to use the test. But certainly we have to compare categorical variables, so that's the treatment and had a heart attack or not. Those are my two categorical variables. That has to be true to do chi-square testing. Randomization being used always has to be true to have any kind of statistical results. And then the expected count in each cell is at least 5. So we have a big enough sample size where all of these numbers it's reasonable to expect all of these numbers to be at least 5. So that's not usually something I would ask on a test, but the hypotheses are very important. So the hypotheses for chi-squared are always the same. The null hypothesis is always that the two variables are independent. And so remember, another way of saying independent is by saying there's no association between them. Yeah. And then another way of saying that the two variables are dependent is to saying there is some association. So you can say it either way. There's a tendency when we're using proportions to think in terms of probabilities, and the words independent and dependent are words that are well entrenched in in probability theory. So that's why they do that. But this is really what those mean, and that's really exactly the same hypotheses for the analysis of variance test as well, if you think about it. So in English, and in words we use a lot, that's what the two hypotheses will be. So if I do this dance with my calculator, or you can do it in what's it called, StatCrunch as well. You might have to Google the instructions for StatCrunch. But either way, I do my chi-squared test, and it's going to tell me that my chi-squared test statistic is 2.27, and my calculator is also telling me that my p-value is 0.1356. Okay, so over 13%. I don't have that on this screenshot. It ran off the page. But that's the p-value that I have. So the conclusion, this is not small, right? So that's not going to be less than 5% or 10% or whatever the significance level is. So my conclusion, which is multiple choice on the homework, but we know what it should say. It should say, since p-value is not small, we do not reject H0. So we do not, this period, we do not have significant evidence that, and what comes after the that is always just HA. It's just the alternative. So we've already taken care of not rejecting means we don't have evidence. So that's already done. The word not's in all the places. What goes in this blank is going to be the alternative hypothesis, and that's true no matter what. If our p-value was small, if we didn't have not here, we would also not have it here. We would reject H0, and we would eliminate this not. But that's all. Everything that goes in this blank is still going to be your HA statement. And so you can just copy the HA right off of where you wrote it down before and whatever words you used. So we could just say aspirin and heart attacks are dependent. It's perfectly fine. However you said it before, in words is perfectly fine way to say it at the end. So in other words, there's some association between taking aspirin and having a heart attack.